Hello, good day everyone. Today is another class for grade 10. It's a physics class. This class was for week 7. So we will continue on this same lesson. We was on current, how current is flowing inside a circuit or through a circuit. Now we will say how current is flowing in a series circuit. So in series circuit, as we can say here, the series circuit can be measured using what? The flowing current here in this circuit are measuring using what? A meter. So the device is used to measure the value of current is a meter, and the device used to measure the voltage is what? Voltmeter. So current in this circuit is moving where? Start moving from positive when this switch is off. When the switch is off, so current start from where? Positive to the minus. It's a start from positive to the minus part. This source of voltage, the sources of voltage here, there are two battery here. This is one and this is the second one. This source, it could be power supply, it could be a cell, it could be a battery, it could be anything for. So this source here is pushing, source of voltage here is to push or to force current to start where? To start moving inside the circuit, start moving from positive, as we said, to the minus part. So the current, the value of I here, or the current I in a circuit, can be measuring using what? Measured using a meter. How a meter is connected in the circuit? A meter is connected, this part is connected with the positive part of the cell here, and the second part here is connected where? To the minus part. So to measure the current inside a series circuit, a meter can be here, can put here, can put here, can put it here, can put it here, can put it anywhere inside the circuit. So if you want to measure the current, for example, in particular component, for example, lamp or motor, so the ammeter must be connected in series with what? With the component. As we said before, this meter, ammeter here, must be connected in serial with what? With this component. For example, motor, lamp, register, any component inside the circuit, ammeter should be connected in series with that component, as we can see in figure 48. This figure shows what? An ammeter in series with what? With a motor. So in series circuit, in this circuit, this kind of circuits, as we said, there are two types of circuits in series and circuits in parallel setup and series setup. So in series circuit, the current is what? The same. Current is the same no matter where the ammeter is placed. As we said, we can put it here, can put it here, can put it here, anywhere, because current is same. The current is same inside what? This circuit. But this is not the case. This is not the case in what? In parallel circuit. In parallel circuit, I is not the same. In parallel circuit, as we said, I is divided between the components inside the circuit. So current inside a series circuit, what happened to the current could be measured by using a meter, as we said. If we are going to measure the value of V here, we can use what? Voltmeter. So we put voltmeter here, is connected like this, minus with minus, positive with positive. So this is V, voltmeter, for V for voltmeter, A for ammeter. Ammeter for measuring I or current, voltmeter for measuring what? Voltage. Another important point, in series circuit, I is same. I inside the circuit is same. Also keep in mind that when this switch is on, so what happened? There is no current to pass through the circuit. This switch must be off to start what? Or to let I start moving from here to here. Also in series circuit, current, as we said, the current is same. As we can say here, in series circuit, current is same through where? Through this circuit. So if this circuit, for example, we have a source of voltage here, or power supply, or two batteries here. The long one is the positive, the small one is what? The minus part. So current start moving from where? From positive, as we said before, to where? To the minus. Start moving from I, the direction of I is from positive to the minus. This is what? Current flow. So where is the electrons flow? Electrons flow is what? In opposite direction. Electrons, because electrons are minus a charge or negative charge, so they will start moving to where? Attracted with which part? With the positive part. Electrons are moving, electron charge are moving this way, current moving this way. So in a series circuit, the current is the same throughout where? The circuit. In parallel circuit, the current, what happened to the current in parallel? Current is split. It's split between the branches or the component or the what do you call in parallel circuit. This means what's this means? This means that the current from the source is large in parallel circuit. For example, if we have a circuit like this is a source of voltage, and then we have like let us one lamp here and second one here, for example, and the third one is here. So the value, for example, if the value of voltage here is 10 V, and this is what? This is first lamp, this is the second one, this is the third one. So the value of phi here, what happened to the value of phi? The value of phi is same. From this point to this point is 10, from this point to this point is 10, to this point is 10. So in series circuit, in parallel circuit, voltage, what happened to the voltage? Voltage is the same. On 3 lamps here. We said in series circuit, current is same. Current through the circuit is same. And voltage, what happened to the voltage? Is split. In parallel circuit, current is what? Is split. Is different here. So current start moving from where? This part, coming where? Up to this point, and then they will split between two parts. This is first part and this is the second part. If we have the value of I here, so we have like I1 here, as we said before, and this is I2. This is split, divided between the two branches. Again, I2 here is divided between two branches here. This value is coming to this way, and this one is coming this way. Here is what? Is combined together again. It's, for example, I3 and I4 combined together to give what? I2. Here, I2 is combined with I1 to give what? The value of total one, which is I. So this means in the current from the source is larger than the current in each branch here, because I1 plus I2, it will gives what? The value of I. So the current, the value here is less. The current from the source here, I, is larger than the two values here, or the two values here on branches is less than the total I. So keep in mind, in series here, current is the same, voltage are divided, So V here in series 1, A1 is equal to what? Equal to I2, sorry, A1 is equal to A2 is equal to A3 because they have the same value. But if you are going to measure the value of V here, it's V1. It's different here, V2. So V here is divided. This one, V, total V here is divided between this and this. Current is same. In parallel one is different. Voltage is same, current is divided. Okay. Now we will have a look at combining resistors. How could we combine different values of R? Different values of R. Two resistors can be placed or replaced by single resistor that has the same effect in the circuit. So calculating the value of the resistor needed depends on whether the original resistors are connected in series or parallel. So when the resistor R1, for example, and R2 in a series, so what's the value, the total value, or RC, complete one? RC is equal to what? R1 plus R2. If we have, for example, like this sort of voltage, and then we have, for example, R1, R2, and R3. It is same if we put R1, R2, R3, the value of I is the same if we take from Ohm's law, we have V is equal to what? I times R. I, value of V is equal to I times R. So R is equal to what? R1 plus R2 plus R3. R1 total R here, R total is equal, this is in series connection, So the value of resistors R, or the total R, is what? R1 plus R2 plus R3, and so on. So in parallel, combining resistor in parallel is different. So the value of R in parallel connection, or the resistors in parallel connection, the combined one is less than what the value of either the two resistors. This is because there are more paths for the charge to pass along, so the current is higher. Yes, the current is higher. So the value of R is less, the value of I is what? Is higher. So keep in mind in series connection that R total is equal to what? R1 plus R2 plus R3 plus R4 and so on. In parallel is different. When the resistors R1 are connected with R2 in parallel circuit, so RC is equal to what? To this. To find the total value of R, it gives from this equation. 1 over RC is equal to 1 over R1 plus 1 over R2, or we can say immediately R total or RC is equal to what? R1 times R2 over R1 plus R2 times over summation times R1 times R2 over summation of R1 R2 to give us what? The R total. So in series circuit, the potential difference PD across the battery equals to what? Summation of potential difference across each lamp. So the value of V is divided between what? Between this is in series connection, potential difference, or the value of V, because the battery is equal to what? The summation of the value of first lamp, for example, plus the value of V over second lamp, or the summation across each lamp. Because V is what? As we said, keep in mind, V in series connection is divided, current is same. in parallel connection, so if we said series connection, so I is same, I is the same, but phi is what? Divided. V is divided. In parallel connection, I is divided, is the opposite. I is divided, and what? Phi is the same. Phi is the same. Say, it's exactly the opposite. This is in parallel, this is in series. I is the same, phi is divided. In parallel connection, I is divided and phi is the same. So what's the total value of R in parallel and circuit? What's the total value of R in parallel circuit? R total is equal to what? The summation of each one, R1 plus R2 plus R3 and so on. Here the total is what? It could be found from this formula. RC or R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 and so on. Or immediately we can say that RC is equal to times of R's, R1 times R2 times R3 over summation R1 plus R2 plus R3 and so on. Okay, so this is a circuit here. This is an example of what? This is what? Series or parallel. This is a series connection. This is a series connection. What we have here in this circuit, we have a source of voltage. There are two batteries here. This is the first one and this is the second one. So the total value of V here is 9. Sorry. The total value here, this one, the voltage here plus the voltage here is equal to what? 9 voltage. So we have 9 volt battery. This is the positive part and this is the minus part. Don't put them in opposite way. So it's not illegal to put positive or minus. No, it should be positive with positive, minus with minus. Okay, this source of voltage. Second component, this first component, for example, of this circuit. The second one is what? 6 volt lamp. This is one lamp here, and this is a second lamp here. 3 volt lamp. So V here, as we can say, the total V is what? 9. So V is what? In series, as we said before, V is divided. I is what? Same. I is still same, but V is divided. So we have 9 here, 9 volt the source. So we have 6 volt here and 3 volt in this lamp. So 6 plus 3 is equal to what? 9. It gives the total value of V. Okay, here we have what? An ammeter A. Ammeter A to measure what? The value of I. The value of I. So I here, we can measure it here or anywhere. Here, even here or before this lamp, after this lamp, before this lamp, after this, anywhere. So the value is keep the same value. The value of I is still the same, which is 2 ampere. 2 ampere. This is what here. This is a voltmeter, BD voltmeter, V1 to measure the value of V over this lamp, and V2 to measure the value of V or PD, potential difference, in this lamp. So first point of the voltmeter is connected with the positive part, and the second one is connected with the minus part. Here is the same. First one point or one terminal of the voltmeter is connected with the positive, and the second one is connected with the minus. So here what we have BD is 6 volt. 6 volt. Actually this voltage here or the source of fault here. Also, this one voltmeter is used to measure what the value of V over the source here. So the source here is what's the what do you call it? What's the benefit to put this value here, or 9-volt battery there? This 9-volt here, or BD, potential difference, is what is used to push the current, to start moving from positive part here. So this battery, when the circuit is on, or switch is on, or connected this way, so it's pushed the current to start moving from here and through the whole circuit and return back where to the minus part. So BD is 6 voltage here and 3 voltage here. BD is what? 6 volt means what? 6 joules transferred from each column. It's 6 joules transferred from each column. Power, the power here is what? The power is 2 coulombs per second, or 6 joules each, 12 joules per second. Power is what? It's 2 coulombs per second, or 6 joules each, 12 joules per second. Here is the same. We can say the same here. BD is 9 here, 9 volts. It's same. So phi, the total phi, is equal to what? V1 plus V2, and I is the same. This is in series. It's an example of what? Of series connection. Okay. Now we will move to, I think, to take an example. Yep. Work with examples, which is on page 279. We have two questions here. First one, 2 resistors 1000 ohm and 3000 ohms are connected in series. So we have two values, or different values of R, R1 and R2. R1 is equal to 1000, R2 is equal to 3000. Are connected in what? In series. Be careful. In series, it's a big difference if we said in this equation are connected in series or in parallel. Keep in mind, it's big different, totally different. So what's their combined resistance? What's the combined resistance of R1 and R2? So R, as we said before, this is a circuit, this is a series circuit. We have what? For example, we have a source of voltage, and we have, for example, this is R1 and this is R2, are connected this way. Actually, R, it could be like this. Symbol of R, it could be, don't be confused. It could be like this. This is R, or it could be like this. They are same. This is what? Symbol of R, resistance. If you find an error like this, so what does it mean? Does it mean the value of 1, it could be adjusted, or adjusted value of R? We can change the value of R to different values. Here it's what? Fixed 1, 5, 6, 7, just one value. Okay, so this one is what? Adjusted, this one is fixed. So we have what? R1 is what? 1000. R2 is equal to what? 3000. So what's RC? What's RC? C comes from where? Combined together. Or you can say RT, R total, or some references said RT, which means R total. Some of them said RC, which is combined resistance. So as we said before, in series connection, RC is equal to what? R1 plus R2. So substitute the values here. So 1000 plus 3000 is equal to what? 4000. So RC is equal to 4000. Yes, note that, or keep in mind that combined resistance in series connection is always greater than the value of either the two resistors. it's the value, total value is what? Greater than what the two values here. Second one, or second question here, extended. We have two registers. It's extended from previous one. We have 20 ohm and 30 ohm are connected what? In parallel. In parallel. So it's not in series. So what's the formula? What's their combined resistance? The combined resistance, as we said, RC is equal to what? You can write it immediately. RC is equal to R1 times R2 over R1 plus R2. Which is what do you call? Multiplication over multiplication of the two values over what? Over summation. Over the summation. Don't be confused. Times R1 times R2 over R1 plus R2. Don't write R1 plus R2 over R1 times R2. So it's equal to what? 20 times 30 over 20 plus 30. It's equal to what? 600 over 50 ohm, which is equal to 12 ohm. 12 ohm. Sometimes you can get what? Not two resistors. You have, for example, 3, 4. So in series, you can say it RC is equal to R1 plus R2 plus R3 plus R4 and so on. In this one, in parallel one, you can say what the R combined or RC or R total is equal to what? R1 times R2 times R3 times I4 over R1 plus R2, R3, R4 and so on. Okay. Okay, now we will move to another topic. Action and use of circuit components. So now you have or you are familiar with how circuits can be connected. So now circuits can be connected in what? In two ways. You are familiar in two ways of connected. Which one? Series 1 and parallel 1. Series 1 you have their own equations, and parallel 1 also we have what? We have special equations for the parallel connection for R and for I or V. So now it's time to consider how components may be put together to make useful circuit. Now we consider with bit advanced how can components put together to make a useful circuit. Use not just simple one. We need to use a useful circuit. So in this section, you will consider the action and use of electrical components. Before that, we need to mention what, as we mentioned in last slide, the variable resistor or the adjustable one. Variable resistor contains what? A length of resistance wire and adjustable sliding contact. Adjustable sliding contact. So the value of of R here is what? It's adjustable. We can adjust it, so we can change it from or for what? Different values. One end of the wire and the contact are connected into the circuit because the contact can be moved from one end of the wire to the other. So the resistance of the variable resistor can be set to any value from nearly zero to what? Total resistance of another values. So it could be started from 0 to large value, for example 120. It has what? Different values in between. This one is very useful. Variable resistor is very useful, as we will say later. Say in this circuit here, in circuit figure 4.54, the voltmeter can be added or put where after the circuit has been made. So what we have here in this circuit, as we said, if you find this arrow, so that means this is what a resistance, or what? Variable resistance, adjustable resistance, adjustable resistance. So we have a source of voltage, power supply, or cell or battery. We have two batteries here, and we have a switch. We use this one for what? This way, say, in this way, there is no current inside what? The circuit. So if you find sometimes it's a tricky way. If you find this one on and give you a question, for example, we have the value of V, value of R, and we will ask you to find what? I. If you find the circuit in this way and the switch is on, so don't do anything, just say what? I is equal to what? 0. Immediately I is equal to 0. To let the current move through the circuit, so this switch must be off. Switch must be off. So variable resistor here is used to what? To control the speed of electric motor. We have an electrical motor here, M. We have variable resistor. We have a battery. We have a switch. We have a motor. We have what? A voltmeter. So as we said here, a variable resistor is used to control the speed of an electric motor, which has a resistance of 12. So this one we have 12 ohm here, 12 ohm. So if it is at 24 volt electrical motor, and the battery with EMF or PD equal to 24 volt, then with variable resistor here set to 0, so potential difference PD cross the motor is equal to what? Is equal to the same value here is 24 volt. So if we put this one on 0, value of R is 0 here, so the same value of V here is what? Will be here 24, and motor will run a full speed. It's a full speed. Okay, now if the PD cross the variable resistor will be 0, here is 0, so the resistance of the whole circuit is what? 12. Yes, so the resistance of the value or the value of resistance of the whole circuit is what? Is 12 ohm, and so current to the motor will be what? 2 ampere. 2 ampere. Why 2? Because we have from Ohm's law, I is equal to what? V times R. We have what? We need to find what? I. So the value of V what? Current is 2. The resistance of the whole circuit is what? Is it 12? Sorry, no, it's not. Sorry, V is equal to what? I times R. V is equal to I times R. So I is equal to what? V over R. The value of R, the value of V is what? 24. It's 24. And R is what? Set to what? 12. Set to 12. So it's equal to what? 2 ampere. 2 ampere. Okay. On the same example, the last one, if the variable resistor is set to 12, this one is 12, not to 0. It's a 12, R is a 12. Then the total resistance in the circuit is now what? 24. Why? Because there is 12 here on this motor, and this value of variable resistor is adjusted to what? 12 ohm. We have 12 plus 12 because they are connected in series, so the total value of R or R combined is equal to what? R1 plus R2 is equal to what? 24 ohm. And the total current can be calculated, what I is equal, as we said before, V over R, which is 24. This one is, the value is 24 here, 24 volt, over what? R, which is 24, so it's what? 1 ampere. We have the value of I is 1 ampere. It's all when the switch is off. Okay, I think, okay. So the current through the motor will have what? Half it, and the motor will run what? Slower. So the speed is slow. Note that we can now work out the PT cross what? The motor. The potential difference cross the motor. Since the current through the motor is equal to 1 ampere and its resistance is equal to 12, so BD or V is equal what? I times R. V, we have I, current through the motor is what? 1 ampere, and its resistance is equal to 12. So the BD, which is the same V, which sometimes it's said EMF, is equal to what? I times R. It's from Ohm's law. I is what? 1 times R is 12, so it's equal to what? 12 volt. So the value of BD, because the motor is what? 12 volt. So it's likewise, the BD cross the resistor is 12, and the BD values around the circuit added up to 24, which is the same as the EMF of what? The battery, as always. So it gives what's the same value on the source or on the battery. Okay, I think it's all for today. Thanks for listening, and we will see you next week, inshallah.